Hi guys, this is Achut. Thanks for watching the second video. So we'll be solving the third video, which is minimum window substring, which is a lead code challenge. So let me explain the question. There we are given two strings S and T, and then we need to find minimum window substring of S such that every character in the T exists in that window. So, and then we are given an example. Suppose if this is the S string and then this is T string, we need to find the minimum window substring. So let me explain what is the intuition behind this. Yeah, before going to the intuition, let me explain like where is the real world example when we are doing the algorithm. So in if we take biology, we'll have DNA sequence where we'll be using some a parent DNA sequence and then there will be child DNA sequence where will be given like at GC. A means adenine and then T means guanine and then T means thymine and then some other things. So we need to find minimum substring in such a way that it will it will be existent in a string which is related to T. So if they are related, then we can say the DNA match will happen, and then we can say like it is 80% matched or 30% matched based on some algorithms. So that will be the real world example for this algorithm, which is a very good algorithm. So let me explain what is the intuition. So suppose this is ABC and we need to have minimum window which is present in S. So we are given ABC. Suppose if we take A and then T and then O and then B and then E and then C till C. So in this particular window, we'll have all the letters which are present in T, right? Yeah. But how can we make it minimum? So we need to cut the left. We need to cut the left when we have like all the elements are matched. So here all the elements are matched. So we'll remove A. But if we remove A, then there will be only B and C in this window. So the matching of ABC will not be happening. So we'll check if all the matched characters are present in the window, we'll try to reduce the window by shifting the left pointer. Suppose if we move the left pointer till here, we'll move A to D and then we'll stop because it is not matching here. And then again we'll go through till here so that it will match, because if we take this particular window then it will be matched. Why? Because it contains A, it contains B, and then it contains C as well. And then after that, as it is matched, so if we see this particular window, we can reduce the unnecessary characters like D, O, B, E, right? Yeah. So we'll reduce it when we have all the matchings, like all the characters are matched, and then we'll be having only COBA. This will be the window where all the characters are matched, and then we'll try to reduce this as well by maintaining the global variable. And then if we move a vote like we'll be moving the right pointer. Why? Because it is not matched as of now. Suppose if we take this is the particular window which we are having right now. So we'll be moving to N, and then so if we take again this window, we have all the characters which is A is here and then C is here and then B is here. So but we can remove unnecessary characters which is O, D, E. So if we reduce this, then this will be the window which we need, like BANC, which is the output we really want. So this is the algorithm we'll be using. Suppose there might be four cases. Suppose if the character is present in the T and then if the character is present in S. Suppose if they are both present in T and S, So we'll increment here, we'll increment here, we'll decrement here, and then whenever we have like 0, then we'll say number of characters matched, number of unique characters matched is increase, like it will be reduced. So first we'll be initializing the variables, which is like left, right, and then we'll be having one map which contains all the characters which are present in T. And then we try to expand the right pointer so that will contain all the characters which are present in T. And then whenever we match with all the characters present in T, we try to we try to increment the left pointer so that it will be minimum window. And then we'll repeat until continuous steps until the right pointer reaches the end of S. This is the for loop, and then we'll return using start. Suppose if we have a string, then there will be start variable, and then there will be length. So from start and length, we can return substring of s dot sub str and then start and then giving the length. So this is the code which we had written. Suppose we are taking year map to track all the characters which are present in T. So we are incrementing every characters which is present in, and then we are going to take number of unique characters equal to mp dot size. Suppose let's say I'm taking T as A, B, C. Then number of unique characters will be 3. Why? Because we should consider A as only 1. And then we'll take left pointer and then right pointer, and then let's take length as int maximum, and starting will be the start pointer where it starts from. It will be the start of the window, and then this will be the length, and we'll be moving the right pointer from 0 to end of the string. Suppose if the character which is present in S, which is also present in T, like which we had implemented here, then we are going to decrement this. And then if suppose if the frequency of A is 5, then it needs to match all the 5 characters. That will happen when we decrement here, and then if it matches to 0, then we can say the number of unique characters will be reduced. And when we have number of unique characters equal to 0, like all the characters are matched, then we need to reduce the window, which will happen when we move left pointer to the right. And then we'll be using the length so that it will keep track of minimum window required to match all the characters which is present in A, minimum characters which should be present in T. So this is the, yeah, when we move the pointer from left to right, then we need to increment maps so that, suppose let's take this example. Suppose when we have ADOBC, when we take out this element, then we need to increment this in the map so that it will be matched in the next check when we are doing the checking. So, and then when it increases to 1, then we need to match again number of unique characters to 1 plus, and then we'll be moving the left pointer. At last, if it is int maximum, then we need to return the empty string, or if it is not int maximum equal to length, then we are going to return the substring. Yeah, that's all for this video. Thanks.